So here we have to find out the value of each of the given expression. So let us begin with question number 1. So we have I raised to the power of n added to I raised to the power of n plus 1 plus I raised to the power of n plus 2 plus I raised to the power of n plus 3 for all n belonging to the set of natural numbers. So we have I raised to the power of n plus I raised to the power of n plus 1, so we can rewrite it as I raised to the power of n times I plus I raised to the power of n times I squared, and the fourth term will be I raised to the power of n times I cubed. Now we can factor out I raised to the power n from each of the terms. That leaves us with 1 plus I plus I squared plus I cubed, which will be equals to I raised to the power of n times 1 plus I. Now I squared is -1 and I cubed is -I. Now we see that each of the term has their corresponding additive inverses, so they cancel out to give us 0, and the final answer will be equals to 0. So this is the answer to part 1. Now we go to question number 2. So here we have I raised to the power of 19 plus 1 over I raised to the power of 25 whole squared. Now what we're going to do is we are going to first talk a little bit about 1 over I, how to solve a problem when it has an imaginary unit on the denominator. So we know that the value of 1 is going to be equals to 1 raised to the power of 4. So we replace 1 by I to the power of 4 and divided by I. That gives us I cubed. So we have I cubed is equals to -I. So we can say that 1 over I is equivalent to -I. So our expression now becomes I raised to the power of 19 plus -I raised to the power of 25 whole squared. Now we further simplify it. So I raised to the power of 19 can be written as I raised to the power of 16, because 16 is a multiple of 4, times I raised to the power of 3 plus -I raised to the power of 24 being a multiple of 4 times -I raised to the power of 1 whole squared. This is 6. Now I raised to the power of 16 is going to be 1. So we have 1 multiplied to I cube. So I cube is going to be equals to -I. Plus, so let's pull out the negative number from inside. So we'll have -1 raised to the power of 24 times I raised to the power of 24. And then we have -I whole squared. So that gives us 1 times -I is -I. -1 raised to the power of 24 is going to be 1, and I raised to the power of 24 is also going to be 1, so that gives us +1 times -I. So we have times -I whole squared. So this value is going to be equals to -I minus I whole squared, which is equals to -2 of I whole squared, and that gives us 4I squared, and the value of I squared is -1, so the final value is going to be equals to -4. Now let's do the third one. So we have I raised to the power of 17 minus 1 over I raised to the power of 34. So we have, for question number 3, we have I raised to the power of 17 minus 1 over I. So we know that 1 over I is simply -I raised to the power of 34 whole squared. So this is the simplified form. Now we can rewrite I raised to the power of 17 as I raised to the power of 16 times I minus, we can take out the -1. So we have -1 raised to the power of -4 times I raised to the power of 34 whole squared. So we have 1 times I, since I raised to the power of 16 is 1, This will be negative 1 raised to the power of 34 will be positive 1. Then we are left with I raised to the power of 34 whole squared. So we have 1 times I, which gives us I, minus I raised to the power 34. So I raised to the power 34 will be 4 raised to the power of 17. 4 times 8 is 32, so that leaves us with an I squared 2. So we have I minus I squared whole squared, so that gives us I squared, negative I squared will be minus of minus 1, which gives us I plus 1 whole square. Now we have to expand it, so we have I squared plus 2 times I times 1 plus 1 squared. Now we know that I squared is equals to negative 1, so that gives us negative 1 plus 2I plus I and 1. So 1 and negative 1 cancels out, it leaves us with twice of I. So in the first question, we have to find the value. So what we will do, we'll consider the numerator and look for the I value with the lowest power. So here we see that I raised to the power 584 as the smallest, that is the smallest power of I. So we'll try to write each of the terms in terms of the smallest power. What I mean to say is, like, we have I raised to the power 584. So I raised to the power 586 can be written as I raised to the power 584 times I squared. Then we go to 588, which can be written as I raised to the power 584 times I raised to the power of 4 times I raised to the power 584 times I raised to the power 6 will give us I raised to the power 590. And the final one, we have I raised to the power 584 times I raised to the power of 8. Then we do the same thing with the denominator. So we look for the power of I, which is smallest. So we have I raised to the power of 574. Then for the second term, we have I raised to the power of 576, which can be written as I raised to the power of 574 times I squared, plus I raised to the power of 574 times I raised to the power of 4 will give us I raised to the power of 578. So continuing with the rest of the two terms, we have 574 times I raised to the power of 6 plus I raised to the power of 574 times I raised to the power of 8. Now we factor out I raised to the power of 584 in the numerator, and that leaves us with 1 plus I squared plus I raised to the power of 4 plus I raised to the power of 6 plus I raised to the power of 8, whole thing divided by I raised to the power 574, which we are factoring it out, and that leaves us with I 1 plus I squared plus I raised to the power of 4 plus I raised to the power of 6 plus I raised to the power of 8. Now we can factor out the common term from both the numerator and the denominator, and that leaves us with I raised to the power of 584 divided by I raised to the power of 574. Then we combine the two exponents of I, so that gives us 584 minus 574, which is equals to I raised to the power of 10, and I raised to the power of 10 is simply I raised to the power of 8 times I squared, which is equals to 1 times negative 1, and the final value is negative 1. Now, for the second part, this is a much simpler one, so I'm doing it here. So we have 1 divided by I raised to the power of 58. So what we do, we consider a value I raised to the power of 60. Now this is going to be equals to 1 because we know that 60 is a multiple of 4, and I raised to the power 4 raised to the power some multiple is always going to give us 1. So we have 1 raised to the power of 60 divided by I raised to the power of 58, which is equals to I squared, and the final value is negative 1.